in the sense of sort algorithm, actually sort algorithm, how sort component or which algorithm is used by sort component and how it works basically in the background in Ab initio. Okay, so like we might have read in our data structure academia, right? Data structures, B sorting, right? Two-way sorting or all those things, B tree sorting and all. So all those mechanisms are based on, like, we have some input data and then there is a sort, right? And then there is an output. So we have these algorithm, like earlier they used to try to divide the data, create some small file which are sorted and then try to merge all those files, sorted files, right, based on the sorting process, and try to produce the output finally. So divide the data, produce some small file, and then try to merge the data, right? Similarly, here also there is a similar thing happens actually. So for with respect to sort component, what it happens is it splits the data, splits and sort and produce the temporary file, and then and merge and then try to produce the output. Okay, so all those things happens, right? So what happens is whenever uh, we configure the sort component, right, in Ab initio, okay, there is a one more important parameter here, max score. So this is the primary memory of the primary memory allocated for this component to do all those activities, right? Sort and merge. Okay. So by default it is 100 MB allocated. Okay, but it is a customizable also. Okay, we can customize it. Okay. So how really the sort algorithm works in background is, like, if you look at over here, so I have a one graph, for example, I have some kind of input data, input file, and then there is a sorting. Or so this is max score, which is by default it is 100 MB. Okay, and how it happens is, like, so if we allocate 100 MB for the sort component, so there are three, you know, uh, three the division of this max score happens in three data area actually: buffer 1, buffer 2, buffer 3. So three buffers would be created. So buffer 1 is for, you know, uh, sorting the data, try to sort and create files, okay, individual files. And buffer 2, whenever buffer 1 creates sorting process, buffer 2 accepts new records. Okay, and buffer 3 is for reserved purpose. So it is not commonly it is not used. In rarest of the rare scenarios, this buffer 3 is getting used. Otherwise this 33 MB, if we have a max score 100 MB, these 33 MB is not, you know, used. So this is the formula of buffer size. So 1 by 3 into max score. So if it is 100 MB, so approximately is going to be 33 MB, right? So the three buffer area, one is area for sorting purpose, second is buffer all the record which has been read, continuously getting read, and this is for sorting, right? So these three things getting created. Okay. Now what happens is, for example, we have some, let's say, 33 MB data. Okay. Okay. So this 33 data came. Okay. For example, we are talking about the ideal case. Okay. Ideal case for 100 MB max score. Okay. This is 33 as an input data. Input data. So what happens is, we have, let's say, 33 MB, right? Let me read 33 MB. So it came over here. We have three spaces in allocation for max score. It came here and it went, let's say, sorting buffer, okay. And these 33 MB is like kind of sorted, okay, within this memory. And as we don't have data in buffer to write, so this is thing, rather than putting into somewhere in the disk, it is going to put into the output file. Because we have only 33 MB, so it is going to be, there is no spillage happens, okay, in this case. And everything is case number one is, so if we have exactly uh, less than or equal to one third of the max score, the input data is one third of the max score, then we see that there is no spillage happens. There could be some special cases where spillage happens, okay, if we are using like nulls, right? So there is a overhead of the data. So whenever we read the data, so there are some things, if it is an ideal case, 33 MB came, then it is fine. Otherwise, if we have like, um, other the overhead is also there. If we are allowing null, if the prefix of the data is sorted, so that is because of some the memory consumed in uh, some other things like to storing the null flag and to storing the prefix of the data, right, for length prefixed vector. So for to store the prefix also we need some memory, right? So altogether what I'm saying is, if your input size is less than or equal to one third of the max score, then we don't have to spill the data into the disk. This is the ideal case for the sort. Otherwise, if let's say this is coming as a 34 MB, for example, so what happens is, or let's say for 50 MB we are seeing in case number 2, okay. So what happens is 33 MB is in this buffer area, but while this sorting happens for 33 MB, rest of the data 17 MB is residing in this. It is buffering in, and this has prepared, and its buffer one is saying that we have more data to sort. He doesn't know that how much is there, but he has sorted 33 MB, and because it doesn't know that, because it's a sort, right? It should know everything, all the data, right? So what it thinks is like we have more data to sort, let's put into the disk rather than putting into the output file. Output file it cannot put, right, because it is a sorting, so it doesn't know what key came in what data, right? So what it does is it will put the data to the disk, right? So it will create another uh, temporary files, temp file 1, and then after what it does is all those rest of the 17 MB record it is getting done, and it will uh, create another file, okay, for the 7 temp file 2. And then what happens is it will try to open all both the files, 33 MB file and 17 MB file, and try to merge, okay. So what is the spillage in this case? All the data, so all the 50 MB is spilled, right? In first case, ideal case, nothing has spilled, but second case everything is spilled because the buffer one doesn't know that, how much data is coming in later, right? But buffer 2 has only 17 data, and all the disk is spilled to there are two files again, and it will try to sort and merge, and then it will produce the output. Now let's say there is an 66 maybe let's talk about 33 and 33 66, right? So let's talk about 66 MB. So what happens is 33 MB is getting sorted and temp file 1 is created. Then 33 MB is there in the buffer 2, and then they are 33 MB coming here, temp file 2 is created. Then they are getting opened by the sorting algorithm, and then try to merge and produce the output, okay. Let's say we have 80 MB now, 80 MB to sort. Now what happens is 33 MB first file created, 33 MB second file created. Now we have 20, 60, 14 MB, right? 14 MB. So what happens is for temp3 is getting created. Now it will try to open all those three files and then try to merge and produce the output. So let's see how much they are spilling. We understood, right? So in this case also 180 MB is spilled. Everything is spilled, right? So what happens is as long as the data coming in which are less than the buffer size, one buffer size, then no spillage happens. Otherwise, everything, all input is getting spilled, irrespective of whatever size we have. Let's say I'm putting 1000 MB also, and this is the max score, then all the things will be spilled, all right, while in sorting the data. Now, who is deciding the spill? When to spill actually? As long as we have less than one buffer size, nothing will spill. But after that, if it is going 1 MB even, 1 byte even, everything is going to be spilled. Okay. So that is the limit. Now, how much max score is getting used every time? So first case, when it is ideal, so what is the max score used? Only 33 MB because buffer 1 is required, buffer 2 is not required because nothing else to be sorted. So the max score required for ideal case wherein the input data size is equal to 1/3 of the max score, there is no, uh, so there is a max score required is 33 MB, you know, and the spillage is 0. In the case of 50 MB, max score required is exactly 50 MB, right? 33 MB or 17 MB, and the spillage is complete 50 MB. And in the case of 80 MB, what is the max score required is 33 MB or 33 MB, only 66 MB. Max score required is 66 MB. There is no, it is the algorithm doesn't use this buffer 3. Okay, so the max score required is always 33 plus 33, 66 MB. Rest data will reside in temporary file at that point in time, right? So the max score required is 66 MB. So the meaning is if the max score requirement, if the input data size is more than 2 buffer size, right? So further the max score required is not going to be uh, required, I think. So the maximum max score would be used is 2/3 of the max score. Okay. So beyond that, it will not use irrespective of the whatever is the input side. Let's say 1000 MB also, the required max score used is 66 MB only because it will read 33 MB, it will put into the temp and disk, it will read again 33 MB. So these two buffers are getting used while processing the data. Rest data, if goes beyond, it will try to put into the temporary file, and then it will try to open all those files and try to sort and give the output. So we have understood what is the max score required at particular input side and particular max score specification, right? And we have understood the when to spill, we understood how much data to spill, and what is the double spillage. So sometimes it happens is I said like whatever is spilling, right? One time it's spilled, right? And it will open the file and then sort and give the output, right? But sometimes double spillage is also happen. So this is the rarest of the rare cases, right? When AB makes simultaneously merge file, this is the configuration variable. Okay. When double spillage happens is, so what is that rare scenario is when their data input data size is very, very huge relative to the max score. This is one thing. In that case, there will be a lot of temporary file is getting created, right? So the size of the temporary file, if you, uh, the formula of the size of the temporary file is three into input size divided by max score. Okay, this is the size, formula for the temporary files. Number of temporary file. Number of temp files. Mhm. So number of temp file is 3 into input size divided by max score. So when the relative size of the input data is used to the max score, number of temporary file, right? Input size is used, max score is less. So number of temporary file which is getting created, right, are going to be very huge. Small files will be created, right? In that case, AB max simultaneous merge file, right? This is the number of simultaneous merge file setting. If this is also less, then what happens is a sort is allowed to open only some of the files, right? If your setting is like less, then what is the meaning of this is when after creating all those temporary file, it will try to open all those files and then try to merge and sort, right? So in that scenario, when this parameter is configured as low and these two conditions happen, like we have a lot of data and also, you know, max score is less, then lot of files are there and we are not allowed to, open all those files simultaneously, then what happens is it will be happening is like, it's allowed only 100, we have 300 files, created, let's say, and it allowed only 50 files at once, right? So what happens is it will open all 50 files and then sort all these files, right? And then try to put again that file into the disk, and those then next another 50 files, another 50 files, 6 times. So what it happens is whenever, so nothing can happen in memory, right? In those cases. So what happens is it will try to spill back the data so that it will upload another file and then it will try to merge and sort. Okay. So this is the kind of rare scenario wherein, so what happens, what is required from development perspective is we need to judge the input data side and the max score size, and we should make sure that so the data, the files getting created are kind of in the range of 1000. So this is the ideal cases wherein we don't create more files than 1000 kind of number of files, right? So this is how sort happens actually. Thank you so much.